Okay, from a frequency table, we're going to develop this idea of a relative frequency. And a relative frequency is really a way to, how should we call it? A way to normalize the frequency table. Okay? So what they have here is a simple formula. The relative frequency is going to equal to the class frequency divided by the sum of all frequencies. So I'm hoping we're remembering some of the vocabulary that we talked about last time. For example, the word class should mean something to you, right? Anybody try to articulate what class means? When I say class in this class? Yeah? A range of values. Okay, specific range of values. Anybody else want to add on to that? Okay. There'll be a range of values, I'll say in a specific category or for a specific interval. So let's make one up, something really simple with like, they say you should have between 5 to 15 classes. Let's make a really simple frequency table with like 3 classes or something. So I'll say let's name this data variable hours and then frequency. And so under hours, we'll say, I don't know what kind of hours this is. Maybe this is the amount of time you spent on the homework between Tuesday and today. So let's say between 0 to 1, or let's say 0 to 2, between 3 to, now, what should the next number be? Okay. Should it be 5? 6? 5? Okay. Now that I asked you that question, I should ask you another question beforehand. I wrote down the first lower class limit and the upper class limit, and then I wrote down the next class's lower limit. And so I'm asking what goes here, the upper limit for the next class. So before I ask you what the upper limit of the next class is, maybe I can ask you what the class width is. What's the class width? 3. It's either 2 or 3, right? The class width is either this, the difference between these two, or the difference between these two. And the correct answer is the class width is going to be the difference between 2 consecutive lower class limits or upper class limits. So the class width is 3. So from here, I can just start counting by 3s for the lower class limits and then start counting by 3s for the upper class limit as well. So 2 and then 2 plus 3 is 5. Good? All right, what's my next class? 6 to 8, and then one more. Oh, I said 3, huh? Well, let's see. How many people spent between 0 to 2 hours on homework? Raise your hand. Let's be honest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many people spent between 3 to 5 hours on homework? Okay, let's just say somebody did. How many people spent between 6 to 8 hours? Okay, let's say another person did. And then we should have just had 3 classes, right? So this is our regular frequency table. Now, what we can do is we can extend this frequency table to construct a relative frequency table. And according to this formula, the relative frequency for each class will be whatever the class frequency is divided by the sum of all the frequencies. So what's the sum of all the frequencies? 18. So our first class, where 16 people spent between 0 and 2 hours on the homework, we'll have a relative frequency of 16. That's the class frequency divided by the sum of all frequencies, which is 18. Now, it's probably okay to leave it as a fraction, but when you're doing your homework, you have to watch out exactly what they're asking you. Usually in parentheses in the bottom, they say, write your answer as a fraction or as a simplified fraction. Sometimes they'll ask you, write your answer as a percentage, and sometimes they'll ask you, write your answer as a decimal to 4 decimal places or something. Okay? So let's express our relative frequency in several ways. So this is a fraction. We can express it as a decimal. Anybody want to punch this in the calculator? Let's say a decimal up to 4 decimal places. Yeah? 888. So if I want 4 decimal places, on the 4th decimal place, I will probably want to round up to 9. And then the other expression that they would probably want is to write this as a percentage with up to 2 decimal places. So how would I? 88.89%. And a lot of times in the homework, they would give you the percent symbol outside of the box where you put in the number. So you just put 88.89. Okay? So the next two are the same. So it's 1 out of 18. And can somebody throw that in the calculator and tell me what you get? 556. Or how would you write this in percentage? 5.56%. So you'll probably be able to write this, or should probably write this a little neater than what I'm doing here. I'm just kind of putting these values on here. So you should, depending on exactly what they want, you would just have, you wouldn't have these equal signs here. You would just pick one of these columns. So depending on what they're asking for. If they're asking for decimal places up to 4 decimal places, a decimal number up to 4 decimal places, then this is what you would put. Okay? Questions? Okay. So, in the example that they give, this is the relative frequency that we were working on. These are the ages of the actresses who've received Academy Awards over the years. And so what they did was they basically threw in the class frequency divided by the total number, and then they got the percentage. So in this case, they're looking for the percentage of the actresses whose ages are between 21 and 30 for the first one, and then 31 to 40, etc. All right, any questions? All right, simple enough. Now, cumulative frequencies. The word cumulative will come up with this word over and over again in this course. Can anybody tell me what cumulative means? Add them all up. And what? Somebody else said something? Addition. So you're adding them up as you go along, right? So that's the tricky part. You're adding them up as you go along. So the first class had, let's see if we can follow this through. The first class has 28, so the cumulative frequency for that class would be 28 because that's just the first number. The next class has 30, so the the cumulative frequency for that class would be the previous class plus the new class that we're adding on. So 28 plus 30 is 58. The next class, you're adding 28 plus 30 plus 12, the latest class, and then you come up with that frequency there. Okay? So by the end, what can you guarantee about this last class? It's the total of the whole thing, right? The sum of all the frequencies, because by the time you get to the end, you would have added up every single one. So as you go along, you would just add up to whatever class you're at, and then you keep adding. So by the end, you would have added up all the classes, so that's exactly the total. So that's the cumulative frequency. Cumulative, adding them all up. If that's what you can think of, or if you can associate cumulative with something else that's being put on top of each other, kind of being added up together, that's exactly what that is. Questions about cumulative frequency? Okay. Now, they didn't mention another one here. Let's see, they don't have it. But there's another frequency called the relative cumulative frequency. So the relative frequency gives the percentage of your frequency. What do you think the relative cumulative frequency will be giving? Backwards. The relative of the cumulative frequencies. That was close. So, let's not talk about that. I was going to do an example with this, but let's do it with this. What if you had a, let's do this in color, purple. Relative cumulative frequency. So the relative frequency, remember, is just whatever that number is divided by the total, which was 76, I think. I know. I lost me. Like I think I mentioned, it's like normalizing it. So it's comparing it to 100%. So if you have a small table, and then you have another table that's a bigger table, usually you would want to compare according to the percentages instead of the actual values. So, blood pressure, yeah. Yeah. And so, yeah, and a lot of times when the numbers get really big, looking at a frequency of 1,000 and then looking at another frequency of 700, those numbers are so big it's hard to kind of compare the values. So this is where the relative frequency might come in handy. Let's see if everything is still running. Okay, we're still good. How do I get rid of it? Okay. Okay. This particular screen is more like a preview to what we're eventually going to run into. Let me backtrack to this. Let's just focus on the frequency distribution here. Oh, we're going to do this, huh? Did we say we were going to do this, or I was going to skip it? All right, let's do it. All right, so I need some calculator help. So instead of looking at the regular frequency table to get the relative frequency, which is how they get the relative frequency, what you're going to do is look at the cumulative frequency and then divide those numbers by the total, which is 76. Okay, so let's use percentages, and let's just round off to the closest whole number percent. And so for the first one, it's 28 divided by 76, but that's 37% because they already told us that from before. So I would say 37% for the first one. Now I want 58 divided by 76 on the calculator for somebody. 76%. Now, one thing to notice, it's cumulative, right? So we're adding on to it, which means these numbers are going to get higher and higher. All right? 70 out of 76. 92%. 72 out of 76. 95%. And 74. 98. And then the last one, since it's the total, 76 out of 76 is 100%. So just like the cumulative frequency, where the last class will be the exact same number as the total, the relative cumulative frequency, the last class will be 100%, because that's what you've accounted for. Okay? So like I said, they didn't go over that in the book, but I thought they did. So we probably won't do it. I'm not too interested in the cumulative frequencies. We will be talking about cumulative frequencies in a different context later on in the course. But for this, for these two sections, or for this particular chapter, I'm more concerned about the regular frequency and the relative frequency. Okay, so back to that critical thinking business over here. The idea of this particular frequency that we're seeing here, that we're looking at, we're seeing a big number 28, and then another big number 30, and then it started to go down 12, and then 2, 2, 2. Okay, so one of your tasks by looking at these numbers, and sometimes maybe this is where relative frequency would come in a little bit more handy, is that when you're looking at these numbers, you try to imagine the distribution. Now, what is the distribution? The distribution, one of the ways to define distribution is how the data looks like in a number line, on a number line. And the best way to describe a distribution is through graphs, which is what we're going to come up to next. And so, have you heard of the normal distribution, or it's also known as the bell curve? So when we think of the bell curve, it's like something that's small and then gets larger and then goes back to smaller. So the question is, if we're looking at that frequency table over here, does this look like a bell curve-ish? No. So a bell curve starts off small, and then the bulk of its data will be collected towards the middle, and then it gets small again. This thing starts off high. It starts off high. So this is our example over here is not bell-shaped. So a distribution would be a way to describe that. And in terms of describing distributions, which we'll get to by the end of this chapter, we'll find a name for a distribution that looks like this. So if the frequencies start low, increase, and then comes back down to low, then that would be like a bell shape or a normal distribution. And then that means it's also roughly symmetric. When they say approximately symmetric, it doesn't have to be exactly symmetric, as long as, as long as it starts low, goes up, and goes back down low. Okay? All right. So let's skip over the recap, and then let's talk about a visual for the frequency table. So these are histograms. So they say a histogram is a type of graph that portrays the nature of the distribution. I'd say it comes directly and graphs your frequency table. So let's add that on. It provides a graphs for graphs your frequency table. So that's your key. You got, if you want to create a histogram, you first need to create a frequency table. So in our example over here, with the actresses again, here's our frequency table. And so what happens is that the histogram takes into account the different classes. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are your 6 classes. Each of those classes has a specific height for your bar graph that describes it. The first one is 28, the next one is 30, the one after that is 12, and then the last 3 are 2. So this is how you would create your histogram. Did you notice the bottom? What are these numbers? Boundaries. So we were talking about the importance of class boundaries. What are they good for? They just look confusing. What they're good for is that it takes your number line and it breaks it up to appropriate tick values. And these tick values allow you to split up your upper class for one class and your lower class for the next class, so that you're looking at this just off of a number line. Okay? And there are these 2 values that are not in between the classes. They're before the first class and at the end of the last class. And so just for the sake of keeping your histogram an even space in between, it's nice to have that first and last boundary. Okay? So I was looking through the homework, and a lot of the homework, they give you the histogram, they give you the frequency table already, and then they ask you to create a histogram. Now, creating a histogram on my math lab is just a matter of selecting, right? Because you're not really creating it. It's a multiple choice question. But in the test situation, I'll probably be asking you to actually draw your own histogram. Okay? So you create a frequency table, and then from there figure out the frequencies, and then you can create your histogram. Okay? All right. So, wait, is this the same? What's the difference between the 2 pages? Sorry, I'm just kidding. All right, let's stay on this one. It looks like the histogram looks the same, right? What's the difference? Percentages. So the drawing that you would get with a histogram gives you exactly the same for a frequency table and the relative frequency table. The only difference is that you're marked with percentages in your histogram if you have a relative frequency table. So really the whole reason for drawing the histogram is to be able to visualize these numbers into a distribution. But it turns out that a relative frequency table gives you a good visual because, like I mentioned before, it's all out of 100%. And so you can see where the percentages are large and small. So if you didn't have a histogram and you want to try to visualize this, I suppose you can go with the numbers that they give you in the frequency table. But if you actually have percentages, I think a lot of people have a better grip on percentages than just the raw numbers. And then, well, it turns out that if you try to draw a histogram for the frequency table and you draw a histogram for the relative frequency table, it'll be exactly the same. Okay? So, any questions? This would be good to do stuff on the calculator. So let's see. Is it calculator time? All right, let's do calculator time. Let's take out your calculators. And let's walk through some steps of putting data in a calculator, and then our first task is going to be trying to create a histogram. So if you have an 83, I think 83 would work just as fine here. And so what we're going to do is we're just going to collect data on the fly. So the way to input data is the stat button right here in the middle. So being that this is a stats class, this is going to be your favorite button for your calculator this semester, stat. And then the data goes into an edit field where it says edit. So whenever you're looking at this number over here and it's already highlighted, you can either press enter to say that is the selection that I'm going to choose, or you can just press whatever number you're interested in selecting. In this case, we want to select 1. So either enter or 1 would do, and then it's going to give me a table. So I don't know what you guys have. I have some junk in my table that I'm going to erase. Do you guys have blank tables, or do you have junk in your table? Junk, okay. So maybe they're not junk. Sorry, I don't mean to call them junk. What I'm going to do is, if you look at where my cursor is up in L1, all the way up to the top here. So it's important that your cursor is up at L1 because you're dealing with the list. I just want to show you something real quick on the calculator. Down here, it tells you what you're dealing with. So it says here that I'm dealing with L1, the whole list. Now, I'm going to arrow down real quick. So now I've highlighted the first element in L1. And down here, it doesn't say L1 equals anymore. It says L1 parentheses 1. So that means this is the first element in my L1, and that first element is equal to 0. You see the difference? Go back up again. That's my whole list. L1, no parentheses, equals to curly brackets, a whole bunch of numbers. Okay? So I want to go up to L1, the whole list, and I'm going to press clear. And I'm going to press enter. So that got rid of my list. All right. Really quickly and honestly, tell me how many hours you spent studying for this class between Tuesday and today. All right, if you want to lie, go ahead. So let's just go in order. 1.5. Well, let's stick with whole numbers. Easier. All right, so to enter a value, you just put the wherever your cursor is. I had L1 parentheses 1 and then equals, then there's nothing there, and then I type 1.5 and then I press enter. Now 1.5 is in the first slot, and now I'm in the second slot and it's blank. Okay? Next one. 1, 2, 2, 2, 0. You could lie. 30 minutes, 0.5. 45? Oh, jeez. That's 3/4 of an hour. I guess 0.75. 2 hours. Nobody's going to lie and say 5. 1.5. 1. 2. 30 minutes. You're the perfect person to lie about this. 1. 2.5. 2. 0. Next. 2. 1.5. 6 hours. There you go. Okay. So, this is our setup. We have some data. This is how you would input data in the calculator. I just collected data. This is like a little survey thing that we just did. But usually you'd have data in the homework problems, and you would just type in that data in your calculators. So you guys have these numbers in your calculators. Just to double check, my 20th element in list 1 is the number 6. So whoops. Let's try that again. My 4th element in L1 is 2. Okay, so that's how you read the thing. And if I go all the way up to the top and list L1, I have L1 is equal to parentheses 1.5, 1, 2, 2, 2, etc. Okay? All right. So we're going to try to create a histogram here. So we want to establish a starting point. A starting point, probably 0 is a good starting point. And then we want to establish a class width. So if you just take a quick glance at this, what would be a good class width? 0.5? 0.5 would probably be good, but that's going to give you individual stuff. It might be a little small. I'd go with 1. 1 would probably be good. So I got a bunch of 0.5s, 45 minutes, and then there's 2, 2.5. So I think having a class width of 1 would be good. And starting with 0. So here's what we're going to do. Let's go to second function. All right, I'm going to clear my history here so that you can see the keystrokes that I'm taking. I'm going to press second function, and then the y equals to, which is essentially stat plot. And then I don't know what you guys have here. If you have anything that's turned on, it might just be safe for us to all be in the same page to press 4. And when I press 4, I'm really accessing this plots off. Everything is going to be plots off. I'm already off, but I'm going to do it anyways. And then enter. Right? So I'm going to go there again. Second function and stat plot. Now I'm going to select the first one because that's the one I'm going to deal with. So I'll say number 1. And the first thing I want to do is I want to turn that on. Right now it's off. My cursor is currently on, so if I press enter, it'll turn it on and it'll remain on. Now what type of graph? Arrow down brings me to my next selection. What type of graph do I have or do I want? I want a histogram, which is the third one on top. So a couple of arrows to the right and then enter. Now I'm going to arrow down. Arrow down one time will give me from type of graph to my X list. So arrow down to my X list. And my X list is in L1. Sometimes you might put your list somewhere else. So mine is in L1. So I'm going to press, it's already in L1, so I don't have to do anything here. But let's just say I want to put L1. So L1 is right above the number 1. But I first have to hit second function. Second function and the number 1 gives me my L1 list. And then frequency for this is going to be 1. Okay? All right. So if you just press graph at this point, which you can, it'll give you a graph, and then the calculator will think up a way of adjusting its class width and height and all that stuff so that it would look kind of appropriate. Actually, that's a good question. I don't know what the algorithm is. There's a way that the calculator computes this, and I don't know exactly how. But I want control over this. I want a class width of 1, and what else did we say? I guess a class width of 1 should be enough. So, for you to be able to control and input your own class width, let's go to Window. Oops. If you had an 83, you'd be on the Window page now. I'm not. Are you guys on a Window page that says X max, X min? How many people have an 84? How many people, when you press Window, it looks like this? Oh, hey, now it's Window. What happened? Oh, well. This is where we want to get at. Yeah? Okay. All right. So my first class will have a lower class limit of 0. So that's the X min. So let's put 0 in for the X min. The X max is going to be, if you want to try to anticipate this, it would be the upper class for the last class. Somebody said 6, right? So 6 would probably be a good place to stop, but I think I might want to go just 1 over. So we can go 6.5 or 7, either way. So let's type 7. Now this is where you get to control your width. So your width is essentially going to be your X scale. So we said our width was going to be 1, so we'll just put 1 in there. Now your Y min and your Y max is going to depend on how large your frequencies are. So I usually like to go -1 for the Y min, just to start off a little bit lower. And then the Y max will be, at the first shot at this, you probably want to just guess how many values you think you'll have. So we don't have more than 20 people in the class, so we could just put 20 and that'll be fine. But I'll for the moment put 20, but I'm going to, oops. By the way, the negative sign, there's a minus sign where you subtract, and there's a negative sign which means the negative number. So make sure you have that difference between those two. So -1, and then Y max I said was going to be 20, which I'll adjust later on. And the scale, usually you just want to leave it at 1, unless you have like this huge amount. We good? Now let's graph it. Oh, I got another graph in there. Do you guys have other stuff going on? Okay, good. I'll take that out later. So this is what we have. Now this isn't very helpful right now because I don't know what those values are. But if you trace, make sure when you're tracing, I hit trace over here, make sure it says P1 colon L1. And then when you hit your left and right arrows, it'll tell you your N is how many values are in that class. So I have N is equal to 6. Next one I have N is equal to 5. My highest one has N is equal to 8. I have some zeros here. And then my last one, there's one person who said that he studied 6 hours. Okay? So now that I know that my highest value is 8, I probably want to adjust my y max to be about 9 or 10. So I'm going to do that real quick. I'm going to go back to window. I have my y max equal to 20 right now, so I'm going to change that into 10, and I'll say graph again. And now it looks a little bit nicer. Okay? So I should have taken screenshots of this and put it on our notes next time. Sorry for those people that aren't here today. Pardon me? This negative sign down here, and then the number 1. So not this minus sign, but this negative sign. So if you hit the negative sign or the minus sign, like you're subtracting, and then if you hit the negative sign, you see that those two are a little bit different. I've gotten used to them, so it might be hard for you to distinguish. But the minus sign is more in the middle and larger. The negative, as in negative numbers, will be a little bit smaller and a little bit higher. So you want to make sure you're clicking on the negative sign. All right, any questions? All right, so maybe I'll take screenshots of this later and add it onto our notes, but probably not exactly. If you go to Frank Austin's hours, he'll have a handout. Actually, I don't know if it's online. So you can get that online, or if you go to his hours, he'll walk through that also again with you. All right. So, is that okay with the calculators? Any more questions about the calculators that we need to talk about? Oh, I don't know. 4 times, 5 times? Nobody gets it the first time. It's recorded, and I think I have videos of this also. And there's a step-by-step process that I have handwritten, and also Frank. So, and as you do your homework, I encourage you to use your calculators. I think there's some value in using Excel when you do your homework, because Excel is a tool that you'll probably use in the future. But for the sake of our class and for the sake of taking exams, unfortunately, I can't allow Excel because it's too hard to manage. But if you use your calculator when you do the homework, then you'll feel comfortable with it enough that when you come to take the test, it'll be second nature. Yeah. Not on the page, no. Oh yes. So on the test, you'll have a piece of paper. So when you're doing your homework, it'd be good to have a sheet, where you do your scratch work. Now, I wouldn't want to list down, 15, 20 numbers just so you can slash them off on a piece of paper. The other option for that is you can try to print it out. I don't know, that's not very good either. So the next step would be just to throw in your calculator and have your calculator do all the work. I'm totally fine with that in an exam situation. Okay? Any other questions? I'll have to take a look at that because they don't allow cell phones at the proctoring environment over there. So we'll talk about it. All right. Any other questions? Okay. Let's fly through the rest of this chapter. So, bell-shaped curve. This is an example of a bell-shaped curve. Here they have really large numbers like 324 and 241. So although it doesn't look like it's symmetric, like exactly symmetric, one on one side and on the other side, that's okay. This is still going to be considered a bell-shaped curve. So bell-shaped curve is approximately symmetric. It doesn't have to be exactly symmetric. So if you get a frequency table and you draw a histogram and it looks something like this, then you can already say this is fairly bell-shaped. And this is generally what we look for. The actresses' ages, they're what we're going to call skewed, and there's going to be some vocabulary around skewed when we get there. Okay. Now this section, it's not that important to me, but there are going to be a couple of graphs that I want us to know. And I think if you printed these things out, which I don't think too many of you did, I switched these values around a little bit. So I'll just make a little note that I say I think this is important. So like this one is important. Or I have a no and no notation. Should I say that? This is a no, and then some of them will be no. So a stem and leaf plot allows you to list the values down where this is a number in a tenths, or if this is in the hundredths place, then it would be in the hundredths place. And then the leaves would be in the ones place. So if you had an original data set, you can create a stem and leaf plot, or if you have a stem and leaf plot, you should be able to obtain the original data. And not only that, but you'd also be able to obtain the original data. So for example, the data, I should do this in a different color. It'd be 21. The 2 in the stem and then the 1 in the leaves gives a 21. The 2 in the stem and the 2 in the leaves gives a 22. There's a 2, 4, 2, 4. There's 2 of them. And 1, 2, 3, 4. And so on. So a stem and leaf plot would work if you have a small enough amount of data and you want to list the data like this. It's almost like a frequency table, except instead of giving you an actual number here, I think it was 28. Do you remember what it was for our actresses? It was 28. The frequency. So if you remember the frequency, here they also go by tens, so that makes it easy for us. So this is from 20 to 29, the ages. And then if you count 1, 2, 3, 4, there's going to be 28 of them. And then if you do the same thing for the next one. Oh, wait, never mind. Their frequency table, their classes are a little bit different from the way these classes are. These classes are forced to go by tens, like 20 to 29. This is 30 to 39. The table for the frequency table that we created for this earlier was going from 21 to 30, so it's a little bit different. But it kind of looks, the same. There's a lot in the first few slots, and then it gets smaller and smaller towards the end. Okay? So stem and leaf plots are important. I'll let you look that up in the book, and you guys will have homework on that. Dot plots are also important, but I won't stress that too much in this class. So this is a no. But I think it's worth looking at. You might have a homework problem or two on dot plots. Dot plots basically has just a regular number line, and they put a dot for, like for example, there's 2 women aged 24 years old when they won the Academy Awards, and there's 2 that's age 32, etc. It just goes in order. Scatter plot. Is something that we're going to focus on later. So in terms of the first test, it won't be on the first test, but it will be later on for our class. I know GIVE is a cumulative frequency dot plot. Remember cumulative frequency? We just talked about that earlier. It goes up. That's not important to me. Frequency polygon. It's like a histogram, except they use dots instead of bar graphs, and then they connect it, so that's not that big of a deal. Oh, by the way, these things would be your what? What? Boundaries? No, not the boundaries. What? No, not the width. What? Midpoints. Class representatives or class midpoints. Remember that? Oh, we'll come back to that later. Anyways, don't worry about that. Pareto chart. This allows you to, this is really a bar graph where you have categorical data, qualitative data. For our sake, I won't be focusing on this. Pie chart would be like a bar graph, again, with qualitative data, or it could be the classes, the quantitative data, but usually when you put it in a pie chart, it means there's some, it's nominal, it's categorical, it's not going to be put in order, so no big deal. Time series graph works well if we're looking at something over time, like the stock market would be something that you would want to plot with respect to time. That's not important for us. And these other weird graphs. There's many other weird graphs that exist. This is actually an interesting graph, so if you want to read through it, this is Napoleon's march. And how many of his troop members he got and got sick and died. All right. So that is the end of the second chapter. Better save this. Oh, I didn't want to do that. Should be save as. Okay, we have another half an hour to get a jump on Chapter 3, so let's do that. You guys tired? You want to take a quick break, or you want to keep going? Keep going. Let's go until 8 o'clock, and then we'll take a break. All right. So in Chapter 3 now, we're going to focus on numerical data. So we're going to focus on quantitative data, where we're going to take a look at trying to measure the center, the variation, and the other stuff that's listed here. Relative standing is another important part. That idea of the frequency table, where we make it into a relative frequency table so we can compare out of 100%, the relative standing has the same sort of idea. It kind of puts a set of data into perspective where you're looking at it compared to everybody else. Anybody know what kinds of things that they would use this for, where they would want to compare it to everybody else? There's a really common, popular thing that's used where you compare it to other things, to other people. Have you heard of percentiles? Where might have you heard the word percentiles from with respect to what? Your what? Your weight? Weight, yeah. Achievement test. What? Income? Income. I guess all those would be good examples. I was thinking about the SAT test, but achievement test is the same thing. So people take the SAT test. I don't know if you guys ever took it or the, what are the other tests? Achievement test, I guess? ACT. So they take that, and then what they do is they report your score, and then they report it compared to everybody else. Because it's always, those tests are, because they change every year, it turned out to be a comparison between what other people did in your group and that particular test. So measures of relative standing is important for that sort of test when you're collecting data. All right, overview. So what we're doing here is the beginning of actually, and also the frequency table, and what we're about to tackle here in Chapter 3 is the beginning of what we call descriptive statistics. Descriptive statistics is basically, describing, it says here, describing some characteristic of a set of data. And this is probably the basic statistics that you might have heard of when people say, oh, the average was, or the standard deviation was, and things like that. They're talking about descriptive statistics. Now, when you take your information from a set of data that you collected and make generalizations or predictions about the bigger population that you're studying, then we have what's called inferential statistics. So, describing the difference between descriptive statistics and inferential statistics will be your first question on your final exam. So these are the two main branches of statistics. There's another study that we're going to do called probability. And probability bridges the descriptive statistics that we're studying to the inferential statistics. So in terms of a mind map, I'm going to squeeze it in here. This is the study of descriptive statistics. This is the study of inferential statistics. Ability. Squeeze in an L and an I there. So probability is going to bridge that gap between the descriptive statistics and inferential statistics. And there's a lot more to probability than, what are the chances of getting a heads or a tail. So under probability is another bigger branch where they talk about distributions, probability distributions, and then that's where we're going to come back and talk about cumulative distributions again. But this is our big overview, and this overview will be revisited again when we start talking about probability theory. Okay, so descriptive statistics and our bridge to inferential statistics is going to be important. Okay, so here now begins our descriptive statistics. We start by looking at a set of data, and we want to imagine where's the middle, where's the center of the data. So it turns out that there's going to be important for us to define what it means to look at the center. And then later on, we'll talk about variation and distributions and stuff like that. So let's focus on the measure of center. So the measure of center, I have to look at my cheat sheet. The measure of center looks at the middle or center of the data. Now, if you remember let's keep coming back to our distribution of ages, the women in the Academy Awards. What is it, 21? And I'll stop here for now. There's 28, and then 30, and I can't remember, 12 or something, and then 2, 2, 2. So I'll draw a rough sketch. So it's going to be exact. But our histogram kind of looks something like this. So our task is, if we want to look at the measure in the center, where is the middle of the data set? So it's kind of tricky for a problem like this, right? Because it's kind of, the bulk of the data set is in one side. So where is the center? Some people might say, oh, maybe we'll make it here, or maybe we'll make it here. It's a little tricky to figure out where the center is. And so the fact is there's several definitions for center, and sometimes it'll be up to us which center we should report on. Okay? When we look at the housing prices here here in the Bay Area, okay, when they report the average, they don't say average. What do they say? The mean? Median. They use the median a lot. And sometimes we use the mean. So mean and median already are two different averages, two different ways to describe the average or the center or the middle of the graph. And then, of course, there's another kind of useless one. It's just from the beginning to the end, from the smallest value to the largest value. Where is the very middle? That's another measure of center that's different from the mean and the median. That's called the mid-range. We'll talk about those as well. So the point is that when you say average, when you use the word average, that could have many different meanings in statistics. So from now on, we'll use the actual word, and I'll start getting used to saying mean or median or mid-range or mode. I'll start with a mean. There's really two types of mean. The other mean we're not going to deal with at all. This is called the arithmetic mean. And this is the average that we know of by adding up the values and dividing it by the number of numbers that you have. Now, in a regular math class, I'd be all up on formulas and stuff, but for this class, I'm a little bit looser on the formulas. But I think there's a handful of formulas that you should be familiar with, and so that in the future, when you see something like this, these are really common formulas that pop up also. So when in the future, when you see something like this, you know exactly what they're saying. So just to get some notation down, I think we talked about this already. We'll use this capital sigma. Remember, I just made a distinction between lowercase and capital sigma. This is capital sigma. To denote the sum, the act of adding up a bunch of things. Now, in algebra, we use the variable x to specify one number, or maybe another few numbers. In this class, we'll use x to represent a whole bunch of numbers that's captured by the data set. So x is the variable to represent each of the numbers in the data set, but when you say X, you mean not just one number, but all the numbers in the data set that we collected. Another notation that's going to be important for us is N. And in statistics, it's used a lot. You're doing statistics, somebody's going to say, what's your N? N is the number of values that you have in your sample. Okay? Now, we talked about the difference between a parameter and a statistic. A statistic is a numerical measurement that describes a sample. A parameter is a numerical measurement that describes a population. And we made distinctions between the different values or the different notation that we use for the mean, for the standard deviation. And it turns out, for the number of values, there is a distinction in the number of total values you have, whether you're dealing with a sample or a population. So for a population, we use capital N. So if you write your lowercase n like a capital N, make sure you start getting used to writing those things differently. Okay? So these are to get ready for the formula that we're going to come up with, and the formula is the mean for a sample is going to be denoted by X bar, and it's equal to the sum of all those values divided by the number of values that you have. And we know that already, except now it's written in a statistical formula that's seen all over the place. This is how it would look like. For a population, it's essentially the same thing, except instead of X bar, you would use the correct representation for the mean for a population, which is mu. And then you would divide it by the total number in your whole population, which is big N. Okay? X bar and mu, we talked about those things already. Just to make another note here, and just to remember and try not to forget our notation, this is a statistic, and this is a parameter. Maybe blue isn't a good color. It doesn't stand out so much. Okay? So we've done this. I don't need an example for this. Let's move on to the next average. Shall we? Any questions about this? Okay. So the next type of average is called a median. What is the median, and what is the difference between a median and a mean? The median is when you put the data set in order, it's going to be the very middle of that. Now, they have, in the book, they have a notation, but it's not as commonly used as X bar. It's not commonly used, so I think I don't like X tilde. So why don't I cross that out and replace it? Just use MED, median. I think that turns out to be more common in papers and stuff like that than tilde, X tilde. And here they make a note that it's not affected by extreme value. Now there's a simple example of this that I have in a video somewhere hidden in my desktop that I'm not going to look for. So let's see if I can come up with a simple example. Let's say we had a company, and the company had 3 people, and I was a CEO, and then we had, what's the other 2 people do? The what? Personal assistant, and then the last person? Bodyguard. All right. So we got the bodyguard, personal assistant, and the CEO of some company. Who makes more, the bodyguard or the personal assistant? Personal assistant makes more. Okay. So let's say we started this company, and I started making $1,000 a week. A personal assistant, how much should we pay him? $300? Wow. It's jacked up. All right, the bodyguard. All right, so this is a simple example. All right, and with 3 people, it's easy to find the median. What's the median? The median is 300, right? Now, can somebody figure out the mean for me in the calculator? Somebody punch this in real quick and figure out the mean. What is it? 700. Okay? All right, now, our company's doing well. And so for the next year, I decided to give myself a raise. We don't need to give those other people a raise. Okay? So if I give myself a raise, now I'm making $3,000 a week. What's my median? What's my mean? What is it? $1,700? Wow. So you see that these 2 different scenarios where we have drastically changing means, X bar changes from 700 to 1,700, while the median stayed the same, tells us something significant about the median. Right? The median's not affected by large changes at one extreme or the other. So that's important. So that's why when they talk about the houses here, the price of the houses, because the prices are, I'm going to use the word skewed, although we haven't formally learned it yet, but because the housing prices are so skewed, reporting the median is a more honest way to go, because that tells you half of the houses are this much and half of the houses are this much. And so the median is usually the best way to describe something where some data set is skewed and you have extreme values. You have $4, $5, and $30 million homes around, somewhere around here in the Bay Area, that really skew the prices up. Is it skew or screw the prices up? Well, one of those. They skew the prices up, and so if you look at the mean is going to look really scary, like scary up high, because the prices are so high for a handful of those houses. This one CEO can mess up your data set, your mean, just by getting that raise. But the median is still going to be the same. Okay, so that's one important difference between the mean and the median. Let's talk about finding the mean and the median. We already know how to find the mean. Let's talk about finding the median. Finding the median by hand is usually not what I would suggest. But if it's a small enough data set, you can find the median, and this has two different ways to do it. If you have an odd number of numbers, like 3, the company of 3 people, the median is the very middle. So if you have an odd number of numbers, there's going to be a middle number. If you have an even number of numbers, like the bodyguard, personal assistant 1, personal assistant 2, and then the CEO, and then whatever they're making their weekly hours. So the median in this case, what you would do to find the median is you would find the 2 middle numbers and then take the mean between these 2. And that's going to be your median. So if these 2 numbers are the same, then the mean is going to be the same. But if these 2 numbers are different, then your mean, your median will be the average between them. By the average, I mean the mean between them. And it's going to be a number that's not part of your list. Yeah?
I have a quick question on the previous slide. Why is the mean 700? Why did we add up 1,400 and then divide it by 2 instead of 3?
Oh, I don't know. I just asked somebody, and that's what they told me.
Okay.
Wait, you got something different?
I got 466.66. Really, the top one. I didn't get the second one yet.
Oh, so why don't we get that fixed up, because these notes will be notes online, so I want to make sure that they're correct. So I'm sorry, X bar was this plus this plus this divided by 3, right? Yeah. And you got what? 466.67. All right, can somebody punch out the second one, please? Okay, not as drastic, but still significantly different. Okay, thanks for finding that. All right. So be careful in finding the means. And I'll show you a way to find this in the calculator, which will kind of make this obsolete. But just so you know, finding the median, there's a process for it. It's also important that you put the numbers in order. Does it say that putting numbers in order here? So maybe you can write that down. Sorry, it's not on this slide. What? Yeah. Let's put it here though, just in case. Put the values in order. And it really doesn't matter whether you're going from smallest to largest or largest to smallest, because the middle is going to be the middle anyways, and that's all you're concerned about. Okay, questions? Here they have an example. I'll skip over this example. If you have it in your notes, take a look at it. It's just an interesting example, but I think it's, I'd rather show you the way to do it on the calculator, and we'll probably get to that a little bit after a break. So let's finish this section. We've got a few more to go. There's no clock. Oh, there's a clock right there. Mode. Mode is the value that most frequently occurs in a data set. And then here they have a couple of other pieces of information. A mode may not always be unique. You could have more than one mode, or you can have no mode. So this is actually a good way to describe categorical data, qualitative data, in terms of finding the average. You know, when they say the average male is named Robert and is 35 years old and it's something, something or other, how can the average male be named Robert? What's that mean? That means out of all the males that they collected data from, most of them said Robert, or Robert was the most named person. Robert is the mode. Okay? I wonder what it is now. What's the most popular name? You guys know? Jack. It can't be Jack. So 1 year was Michael and Hannah for boy, male and female. 1 year is Robert and something else. I forgot. Recently it's like Emma or something. Emma was really popular. So, yeah, that's something you could probably Google. So, mode is a good way to find, and I'll put average in quotes. It's a good way to find the average for nominal data, for qualitative data. Yeah, somebody told me one time the average Cañada College student is a female who was 26 years old and was majoring in psychology or something like that. That was a few years back. That means there was more females than males at that point where they got that statistic from. Okay. One more central measure of central tendency is the mid-range. So the mid-range is really just taking a look at two values, the very smallest and the very largest, and finding the mean between them. So out of all the definitions for central tendency, this is about the most useless. In a way, it is important because it marks the very middle of the data set if you're looking at the number line. But in terms of actually measuring with respect to the different data points that you have, it doesn't take into consideration any of the, where it bulks up. If it all is concentrated towards the middle, we have like a bell-shaped curve, sort of, and then you can tell that the mid-range and the mode and the mean and the median are about the same. But when your data is like the actresses, it's skewed to one side, then the mid-range is really not helpful at all. And in most cases, a lot of our data is skewed, so our mid-range is not very useful. But it is still an important calculation for us in statistics. Now, in the homework, when you do homework, they tell you exactly how to round off. When they ask for a particular problem, they ask you to find the mean or they ask you to find the median. They tell you to round off to a certain number of decimal points. But the general rule of thumb is that you look at your original data and then you round off just one more decimal point after the data. So if all your data are all whole numbers, then you round off to one decimal place. If your data, for some reason, like our data we collected, 1, 1.5, 1.5, 2.5, 0.7, let's just say 0.7. So if your data set has is given to you, usually they're consistent. They would give you all the data set in 1 or 2 decimal places. In this case, the data set's in 1 decimal place. If you were to find the average of this thing or the mean of this thing, you would express your answer in 2 decimal places. So with respect to your original data set, you would carry your result one decimal place past what you're given. Okay, I think. All right, the next topic is trying to find the mean from a frequency distribution. This is going to take a little bit of time. So this will probably be a good time to take a break. Let's take a 10-minute break, and we'll come back. We'll power through the rest of this chapter.